Today we're going to check out solving one-step equations, and the first portion here we're going to look at using addition and subtraction to solve equations. So first thing here, an equation, the official definition is it's just two mathematical expressions that are equal. Up until this point we've seen some expressions that we've simplified either via the distributive property or order of operations. There hasn't really been an equal sign involved, so now we're going to have two sides going on. So an example would be x plus 3 equals 5. And in order to solve any equation, we have to isolate the variable in the equation using inverses in order to keep the balance of the equation in check. So in order to understand this, we got to look at properties of equality. Very simple. So if we start by looking at something as simple as 3 equals 3, I can add any two numbers to each side that I want to, as long as they are the same number. So you can see they add plus 2 to both sides, and we end up getting 5 equals 5. Same deal with subtraction. If I start with 7 equals 7, true statement, and I subtract 5 on both sides, we end up with 2 equals 2. The reason that we're pointing this out is because we can do anything to both sides of the equation as long as it's the same operation. In fact, whenever we do something to one side of the equation, we have to do that same thing to the other side of the equation. Think of it like a balance, where if we had something kind of like this, it's going to be a very bad drawing of a balance, but you've seen it before, where if you have weights on one side and the other side, in order to keep them balanced, we have to keep the weights the same. So let's say we've got, I don't know, some more boxes on this side, and let's say we take away a blue box on one side, we're going to have to take that away on the other side too in order to keep the balance or the weight the same. So you've probably seen that before, but that's the idea behind solving an equation. So mathematically, when we look at this, what I like to do is draw a line down my equal sign. And that just helps me remember that whatever I do to one side, I have to do to the other. And I always find my variable first. So for a here, I have x as my variable. And then I like to ask myself, what's happening to that variable? Well, we're taking away 10. So if we're taking away 10, I'm going to use the inverse then to figure out what's going on here. So I'm going to add 10 instead. And the reason I'm going to do that is because negative 10 plus 10 cancels each other out, and I'm left with just x. Remember, we want to isolate the variable, get it back to we want to get it by itself. So 1x or just x equals, but I also have to add 10 to this side since I did it on the other side. 4 plus 10 is 14. So 1x or just x equals 14. And if you ever want to check to see if you got that right, you just plug that answer back into your equation. So I would look at, I would put my 14 back into x, so 14 minus 10 does equal 4, so we're good. Right? So we can check that very simply. With b, kind of the same concept, except for I look at what's happening to m. I'm subtracting 1/5, so I'm going to do the opposite of that and add 1/5 to both sides. These cancel, and then I've got 2/5 plus 1/5. We get 3/5. Okay? So pretty simple when we're looking at addition and subtraction. Looking at these real quick, we'll just go through them and then that'll be it. So we'll solve for a. What's happening to it? We are adding to a, but we're adding a negative 7. So what I really want to do here is add 7 to both sides, because adding a negative is just like subtraction. So negative 7 plus 7 cancels. I'm left with just 8 equals 17. Letter B. We are subtracting 9 from a, so I'm going to do the opposite. I'm going to add 9 to both sides. A equals 19. And lastly, this one's got a little bit of a trick to it. We've got 5 minus x. Now, most people would want to say, well, I want to add 5 to both sides because they see the minus sign. But that's not the case, because what is 5? 5 is positive. I could rewrite this as negative x minus 5 is 0. I'm left with negative x, though. And then 2 minus 5, I get negative 3. So if negative x equals negative 3, positive x, which is what we want, we don't want negative x, equals positive 3. And the way that we kind of get rid of that mathematically, rather than just thinking about it, is I could multiply both sides by negative 1. Remember, I can do one thing. If I do one thing to one side, I have to do it to the other. Well, negative 1 times negative 1 times negative 1 gives me positive 1. And then negative 1 times negative 3 gives me that positive 3. Mathematically, that's what's going on there. And that's how we would get around that situation. All right, so that is one step